Hi all, today I am presenting my ambient occlusion assignment. Ambient occlusion is the occlusion shadow caused due to ambient light and not the direct light. So there is an algorithm called screen space algorithm to calculate the ambient occlusion. So as you can see here in the picture, for point P1, all the lights that are in light color contribute to the illumination of this point, and all the light rays that are blocked from this point P contribute to the occlusion of this point. Since the calculation of light from each direction will be very costly, so Crytek has suggested a solution that is called screen space algorithm for calculating ambient occlusion. Here what they did is at a point, suppose P, they have taken a sphere, and in this sphere they have taken some sample points that are shown here in black color. On these sample points, a jet test is performed. All the sample points that are passing the jet test contribute to the ambient occlusion, while others do not. Ambient occlusion in action. Here I am inputting sample radius. Suppose I have given 10, and then I am rendering my image. You can see here there are three spheres, white, green and black, and for simplicity I have not implemented shadow mapping or any of shadow things here, and you can see the shadows that are created only through ambient occlusion. Next, if we want to see only ambient, just click on this only ambient occlusion button, and you can see the jet test performed here with ambient occlusion, and all the colors are removed. We come back to our color, and if you want to verify whether these shadows are due to ambient occlusion or not, just click on this no ambient occlusion, and you can see there are no shadows. Now if you want to change the radius of sample screen, then just enter any other radius, and you can see the shadows again came with higher radius of sample screen. Now let's go to our code. I am creating a scene here which includes colored ball material, then white ball material and black ball material. Then I am assigning these materials to the spheres and adding them to the screen. And then I am adding the plane surface ground wall that is present there, and then I am adding the ambient light, and then adding the camera and its position. Next, for adding the screen space ambient occlusion, we would require depth of the materials. So we can take it from the screen or created by the 3JF with this code, and this depth shader will get us the depth of the materials. And next, I have written my own shader for screen space ambient occlusion. So including it in the renderer, we have to pass it as a shader path. In the shader path, and here I am providing all the input values for this screen space ambient occlusion shader that I have written. Now let's see the shader. Uniform contains all the input variables that you have to provide, and you have to provide some default values as well. And then I have written the vertex shader, and this is the format that is provided by the 3JF, and you can see these lines are the part of WebGL renderer, and they are included in the inverted comma because we have to pass this shader as a input string, and then this will be passed by the 3JF and included in the renderer as a native WebGL renderer. So next, I have taken all the inputs that are provided here in uniforms, and I am taking the samples count as 12, which is a constant for this screen space, and taking the screen space radius as an input, since we require this as an input as a requirement in the assignment. Next, let's go to the main function where all the logic starts. So we have got all the depth and variables. Then ambient occlusion is the variable which stores the contribution of every sample point in a UV. And I'm taking sample points for each VUV for each vertex of the fragment. Then I'm calculating the ambient occlusion contribution of each sample. For calculating the ambient occlusion contribution, we have to pass them through the jet test or depth test. So for that, we are comparing the depth of coordinate 1 with the coordinate 2. And this depth extrapolation is required to avoid self occlusion. And after this ambient occlusion contribution is calculated for each sample, we are using this formula and multiplying it into the luminance of the point. Then this logic is for the part where I was showing whether it's with the colors or only with the ambient occlusion. So for that, I'm multiplying it with the original color if we are not showing only ambient occlusion, and I'm not multiplying it with the original color of the pixel if we are showing only ambient occlusion. So for those functions, I have written only ambient occlusion, where I pass the only AO value as 1, which sets the flag. And if no ambient occlusion is required, then I am setting the screen space radius at 0. That means I am not calculating any ambient occlusion. And this is the output. And thank you for watching my video.